So it says here, consider the demand equation. So here we're given this demand equation, P equals, so remember this relates price to quantity. So I have that. And this describes the relationship between the unit price in dollars and the quantity demanded of some loudspeaker systems. We're asked to find the elasticity of demand, that function E of P. And remember, this formula is one I will give to you, so I'm going to go ahead and write it out for us here. So it's minus P times the derivative of F of P divided by F of P. All right, so there's our function. The first thing that we have to do for part A to find that formula is we need to rewrite this with x on one side and p on, basically x by itself on one side and p on the other side with everything else. So we're going to write this as a function of p. So I'm going to go ahead and rewrite my function. Alright, and I'm going to go ahead and bring, let's go ahead and just switch these two terms here. So I'm going to rewrite this. I'm going to bring this over to this side. It's going to become a positive 0.02x. And this is going to become a negative p. All right, then I'm going to get rid of what's in front of x. And I'm going to divide by 0.02 on both sides. Okay, we want to get x by itself on one side. We're going to write this as a function of p. So we end up with x is equal to, and if you put into your calculator 1 divided by 0.02, you end up getting 50. And so I'm going to go ahead and I'm going to just write that. And that's a negative value. So I'm going to say that's negative 50 times p, just to make that look a little nicer, a little simpler. Here I get a positive 400 divided by 0.02. If you put that into your calculator, you end up with 20,000. So I'm going to go ahead and just write that. So this is our function of p. So f of p is equal to x is equal to all of this. So this is my function of p, where p is the independent variable here. Okay, so first step here is to rewrite it. So I'm going to continue on. I'm going to find the derivative of this function with respect to p. All right. Okay, so first of all, let's just go back to our formula. Negative p, so we're going to put negative p there. This is the variable, so that doesn't change, negative p. Now I find the derivative of our function here. So I'm finding the derivative with respect to p. So this is actually really easy. Treating p the way that we would have treated x before, the derivative with respect to p would be negative 50. Kind of like if you had negative 50x. And we say the derivative is negative 50. We're treating p the same way we treated x before, so the derivative of that would just be negative 50. And of course this is a constant, so that's just 0. So here we have, let me put this in a different color. Here we have the negative p from the formula, and then now I'm finding the derivative of f with respect to p. So I look at this term, the derivative of that would just be negative 50. So negative p times the derivative of that demand function with respect to p there. Then I'm going to divide by the original function. So I'm just going to divide by negative 50. Oops. P plus 20,000. Okay, so our first step was to form that demand function of elasticity. So elasticity of demand function E of P is equal to negative P. That's always going to be negative P. I'm not going to do anything with that. I'm just going to copy it down. Find the derivative of our function. Put that next. And then divide by the original function. All right. So there's our elasticity of demand function E of P. So remember, I'm going to give you this formula. You just have to know how to use it. It says here to compute E of 100 and E of 300 and interpret our results. We want to know, is the demand elastic, unitary, or inelastic? So here when we plug in 100, we're talking about a price of 100. So I'm going to put a line here. I'm going to say this is part B. So I want to know if I'm charging whatever I'm selling here, which is selling some loudspeaker systems. If I'm charging $100 currently, and I want to think about raising my price, and I want to know how that's going to affect the demand, how that's going to affect the revenue. We want to know basically, should I raise my price? Is it elastic or is it inelastic? Is it unitary? Is it a good idea to change my price? Am I going to start losing money or is it going to help me gain money? So if my current price is $100, let's see if that price point is elastic or inelastic. So I'm going to say E of 100. And I'm going to put that into my function everywhere I see a P. So that's negative 100 times negative 50 divided by negative 50 times 100. So I'm just putting 100 everywhere I see a P in my function. All right. And I'm going to simplify this. At the top, I'm going to end up with positive 5,000, and the bottom end up with 15,000. So we end up with 1/3, or 0.3333, etc. Okay, let's think about this as kind of a percentage rate of change. So let's put this over, let's think about putting that over 1. Okay, so 0.333 divided by 1. Basically what we're saying here, and I'm just going to put little percentages here to kind of help us think about that as a percent rate of change. The top value talks about demand. Now, before we go on, let's just rewind a little bit, go back to our original function. So when we talked about the original where that function came from, the top number, the top value was the quantity of change, the relative rate of change of the quantity demanded. The denominator was the percent rate of change of the unit price. Okay, so demand is on top and unit price is at the bottom. Okay, so we need to be able to form the function E of P, which we did. Now we need to be able to plug its values and prices into our function, which we did. Now we want to interpret the results. So what does this mean? Okay, well, demand is at the top. Okay, demand, we said if we raise our price, demand is always going to go down. So demand goes down by 0.3333%. The bottom number is talking about the price. So I raise my price, demand goes down. But the demand is only going down by 0.3333%. If I raise the price by 1% and I lower, and my demand only goes down by 0.333%, then I'm not so much concerned. We would call this an inelastic demand. Okay, so let's go back up one more time. Let's go back up to here. We said here that if our function gives me a value that's greater than 1, then we have something elastic. If the function gives me something out that's less than 1, then we're inelastic. All right? So keep that in mind. That's why I've decided this. So this number here, 0.33333, right here, turns out to be something that is less than 1. So since that value turns out to be less than 1, then we have an inelastic demand. Okay, what does that tell me? That tells me that my revenue then will increase. So my demand is not affected. My customers here are not price sensitive. They're price insensitive. I raise my price 1%. My demand is only going down by 0.33%. So it's not going down that much. So I would like to raise my price because if I raise my price, my revenue will increase. Okay, so price goes, you think about price goes up. Let's put the little up arrow there. Price goes up and revenue also goes up. They move in the same directions. Oh, we were also asked to do 300. So let's look at 300. What if I'm charging $300 currently? Is that an elastic or inelastic demand? So we're going to plug in 300 now in place of P. So I'm using my function here, E of P, so E of 300, that's my price. So then I get negative 300 times negative 50 divided by negative 50 times P of 300 plus 20,000. Alright, so what do we get here? So now at the top, when I plug that into my calculator, I get a positive 15,000. And at the bottom I get a positive 5,000, which gives me 3. So the number that I get out for my demand of elasticity turns out to be 3, which is definitely greater than 1. This tells me that the demand is elastic. That means my customers are price sensitive. Okay, so let's think about this as that fraction like we thought about it before, up above. 3% over, let's divide that by 1, so over 1%. So this means that if I raise my price by 1%, my demand is going to fall by 3%, which is a pretty substantial drop in demand when I change my price by only 1%. So elastic, very price sensitive. My customers don't want me to change my price. They don't want me to raise my price, or a lot of them are going to quit buying. So in this case, since I have that elastic demand, the revenue then is going to decrease. So my customers are going to quit buying. A lot of them are going to quit buying. My revenue, the money that I'm bringing in, is going to start to decrease, and that's what I do not want. All right, so you'd answer this question for a price point of 100 and a price of 300. Part C up here is asking us what we already talked about. If the price is $100, will raising the price slightly cause the revenue to increase or decrease? And we've already said that that would cause our revenue to increase. So if we raise our price, our revenue will go in the same direction. Our revenue will also increase. All right. All right, and our last example here, elasticity of demand for hair dryers. The demand equation for the Roland portable hair dryer is given by, and what's nice here is that our function is already written with x by itself on one side. So we already have this as a function of p as my independent variable, so we don't have to rewrite, which is nice. X is measured in units of 100. And that's the quantity demanded per week, and P is the price in dollars, so that unit price in dollars. Is the demand elastic or inelastic when the price is $8 and when the price is $10? So before we answer this question, obviously we have to find our demand, our elasticity of demand function. So I need to find E of P. So we know that the formula for that is negative P divided by the derivative of that demand function divided by the original demand function. All right, so let's go ahead and make that formula. So it's always negative P. That part doesn't change. We want to find the derivative of our function. One thing that we can do here to make this derivative easier is we have this 1/5 out front. We can actually multiply that into the parentheses here to make this formula a little bit easier to work with. So let's go ahead and do that. We get x is equal to 1/5 times 225 actually gives me just 45. 1/5 times negative p squared is 1/5 p squared. So we'll just leave it like that. So I want to find the derivative of this and put it behind the negative p. This actually turns out to be a really easy formula because when we take the derivative of that term 45, that's just 0, so we don't have to write anything down. And I'm just going to use my power rule here. 2 times 1/5, well, that's negative 2/5. And then lower my exponent by 1, so I just get p to the power of 1, or just p. And then I'm just going to write down f of p again at the bottom, which is just 45. Just going to copy it right down here. 45 and then minus 1/5 p squared. Okay, so there's our elasticity of demand function. So not too bad, especially if it's already written with x by itself on one side. We just got to take the derivative of it, and everything else is pretty simple. Now what you could do is you could rewrite that a little bit with decimals if you so chose. So let's go ahead and do that. Instead of having those fractions, let's go ahead and rewrite this with decimals. All right, a couple of different ways you can go about simplifying that. So let's say 2 divided by 5. If I put that into my calculator, I actually get 0.4. So I'm going to put negative 0.4 times p. And if I put 1 divided by 5 in my calculator, I actually end up with 0.2. All right, I'm going to do one more thing to make this look a little bit simpler. So let's just come down here and rewrite this one more time. If I multiply across the top, we give a negative p times a negative 0.4p. Well, negative times a negative is a positive, so I'm going to get a positive 4.4, and then p times p is p squared. And the reason why I'm simplifying this is because we're about to use this formula, and it makes it a whole lot nicer if it's simplified as much as possible before we actually go use it. Alright, so let's go and answer our questions. Part A, is the demand elastic or inelastic when P is equal to 8? And another question, what about when P is equal to 10? So what about when our price is $8? So we're going to take that value, we're going to throw it into our equation. So get 0.4 and then 8 squared divided by 45 minus 0.2 times 8 squared. Okay, I'm just going to throw all of that right into my calculator. I'm going to get a value for the top. I get 25.6. At the bottom, I get 32.2. And then I'm going to just throw that into my calculator again, and I get 0.795. So is this elastic or inelastic? The number is less than 1. So we would say that this is inelastic. All right. And let's explain a little bit about how we decided that. So if we put in 8 into our function, we got out about 0.79, let's say. Okay, and you can simplify that as much as you want. But about 0.79, let's think about that as a fraction and think about the percent rate of change. We know that the demand, we said that we assume that the demand always goes down when the price goes up. So the price is raised by 1%, but the demand goes down by a lot less than that. The demand only goes down by 0.79%. So that means that my customers are not very price sensitive. They're price insensitive here. So if I raise my price, they're still going to buy it anyways, most of them. Enough people are going to buy it to where my revenue will increase, and I'm happy about that. So that would be inelastic. Okay, what about a price point of $10? Let's say I'm charging $10 and I raise my price. What's going to happen? Let's decide if it's elastic or inelastic here. So I'm going to put in my 10 into my function. Okay, so everywhere I see a P, I'm going to put a 10. And now at the top I get 40. And in the denominator I get 25. So it looks like I get about 1.6. Okay, well that's greater than 1. If that number that comes out of my function is greater than 1, then we would say that this is elastic. Okay, and so the explanation here, why did I decide elastic? Do I want to do this? Is this something I want to do? So let's think about this as a fraction. So 1.6% over 1%. So if I raise my price by 1%, the demand decreases by substantially more. It decreases by 1.6%. So I have a lot of customers that are going to stop buying. So that is not what I want to do. So I don't want to raise my price by 1% because my demand is going to take a pretty big hit. I don't want that. Okay. Let's answer the question for part C. So we've decided elastic and inelastic for those. Let's go to part C here. It says, if the unit price is lowered slightly from $10, will the revenue increase or decrease? Let's answer part C here. I'm just going to put part C for both of these here. So it says, if the unit price is lowered from $10, so we're down here. So if I lower my price, then what's going to happen? Well, remember, elastic means my customers are very price sensitive. So if I raise my price, I lose a lot of them. If I lower my price, then I'm going to gain a lot more. Okay, so in this case, if I lowered my price, so keep in mind that that's what it's asking. If you lower your price, then we're going to say here that the revenue would actually increase because you're going to get a lot more customers. I say this was part C. I'll just say revenue increases. Okay, we'll change this to part D. Okay, what about part D? It says here, if the unit price is increased slightly, so increased here from $8, what will happen to the revenue? So remember that in inelastic, my customers are very insensitive to price. They don't care if I raise it or lower it. They're going to buy it no matter what. So if I increase my price, then my revenue is going to move in the same direction. My revenue will increase. So my customers are going to buy it even if I raise the price. They're very price insensitive here. All right. Part B, and let's take up a little bit more room for this. Part B says, when is the demand unitary? So unitary means when are you charging the exact perfect right price? You don't want to raise it, you don't want to lower it. This is basically your maximum revenue. So what price should we charge to maximize the revenue? And it says here, there's a hint. We want to set the demand function that not the demand function, but the elasticity of demand function equal to 1 and solve for P. All right. So we have part A, part C, part D, and so I'm going to come down here in part B. Okay, so we want to figure out when E of P equals 1, then P is equal to what price? So what is that ideal price that we should charge? And when the function gives us something out that is 1, then we call that unitary. Okay, so the demand is unitary, it says there. Okay, so not inelastic, not elastic, but it's unitary. Okay, so remember, inelastic means that my number that I get out is less than 1. Elastic means that it's greater than 1. What if it is exactly 1? We call that unitary. Okay, so we're going to take our E of P function, which was that 0.4 times P squared, divided by 45 minus 0.2 P squared. We're going to set that equal to 1. We're going to solve for P. So the first step here is to set that function equal to 1, and now we're going to solve for P. Alright, so in order to solve this equation, we're going to do 1 over 1. So I'm going to basically write both sides as a fraction. And then I'm going to cross multiply. So 1 times the denominator gives me right back to that denominator. 1 times the numerator gets me right back to the numerator. It's actually a really easy equation to solve. Just set it equal to 1 when you see the word unitary. Think about the word unit and 1 kind of being the idea of a unit. Set the function equal to 1. Really easy equation to solve. We cross multiply. Alright, a couple of different ways we can go about solving this. This is a quadratic equation. I'm going to go ahead and just add 0.2 P squared to both sides of my equation to get that P by itself. So we end up with 45 equals 0.6 P squared. And then I'm going to divide both sides by 0.6. Let's see, when I put that into my calculator, I end up getting 75. And of course these are going to cancel. That's equal to P squared. And then I'm going to take the square root of both sides. So I want to get to P, not P squared. And our price is only positive, so I'm not going to do plus minus here. So I get about $8.66. So this is the ideal price that we want to charge. This is what's going to actually maximize the revenue, maximize the amount of money that we're bringing in. Okay, so this is when the demand is unitary. This is the price point. This is the ideal price that we should charge. So $8.66. Okay, so let's go back to right here. So this is where basically all of the information is that you need to answer a lot of the questions right here. All right, so keep in mind that elastic means price sensitive. Inelastic, your customers are price insensitive. Keep in mind that when you use the formula, what it means when you get something greater than 1 and less than 1, and how to interpret that. It's either elastic or inelastic based upon being greater than 1 or less than 1. If the formula gives you out exactly 1, then we would say that the demand is unitary, so that means you are charging the ideal price. that is exactly what you want to charge. So you set that function equal to 1 and solve for P, solve for that price. All right, so go back to this page right here. Everything you need to know, including the note, is all right here for elasticity and revenue, and if you should raise your price, and if you should not raise your price, depending upon if it's going to hurt your revenue or not.